Hello, cloud gurus. You're using Kubernetes to run your applications, and those applications are going to have data, and that data needs storage. So let's talk for a minute about storage in Kubernetes. Now, most applications that are run in Kubernetes are stateless applications. However, it is possible to run stateful applications as well. But with stateless applications, it's assumed that they die and they are never brought back to life, and any storage inside the container or pod is lost when that container dies. So you think about these deployments where you want to scale up and add 50 more pods running an application, and then later you scale down back to 25. You might even enable auto scaling so that the number of pods is constantly going up and down based on the load. And even if a pod crashes, when it's restarted, the data that was in that pod dies with the pod. And this is called ephemeral storage, and that's not going to work for stateful applications. Stateful applications need stateful storage, and even many stateless applications will still need to be able to share storage between the pods for the applications to function. Not to worry, Kubernetes has a solution for this, and it's called Kubernetes Volumes. And as usual, Kubernetes offers a lot of flexibility on this. There are many different types of Kubernetes volumes. In fact, too many to list on a slide. If we go over to the Kubernetes documentation, you'll see here, if we click on types of volumes, there are many different types of volumes available to you, including AWS, Azure, Ceph, Cinder, CSI, Flocker, GCE, Gluster, iSCSI, Local, NFS, Storage OS, vSphere volumes, and more. If we click on CSI, though, I want to show you CSI because CSI is an important type of volume. This is the container storage interface known as CSI. And most storage vendors out there today have created what they call a CSI compatible volume driver. So if you have some kind of storage array out there, chances are it offers a CSI or container storage interface volume driver. Volumes are typically created using the declarative model with a YAML configuration file, and that's because volumes are a resource just like anything else in Kubernetes. Kubernetes has what they call a persistent volume, or PV, which is storage that has been provisioned by an administrator or dynamically provisioned using storage classes. And then a PVC, or persistent volume claim, is a request for storage by a user. So PVs are created, and then PVCs are what consume the storage that was created. Some of the commands that you need to be aware of are kubectl get PV to get the list of persistent volumes that have been created, kubectl get PVC to get the list of persistent volume claims, and then you can describe both persistent volumes and persistent volume claims. Let's go over into the lab and I'll show you how some of these commands are used. I encourage you to follow along. To see what persistent volumes we have available to us, we're going to type kubectl get PV for persistent volumes. And by default, of course, you won't have any persistent volumes. The only reason that we have two persistent volumes listed here is that if you recall, in a past lesson, we deployed WordPress and WordPress MySQL, and to do that, we used manifest files. If we take a look at the persistent volumes that we have currently created, notice here that both of them are 20 gigabyte persistent volumes. They have access modes that have been configured to read, write, and they're currently claimed, which means that they're currently in use by the WP PV claim and the MySQL PV claim. You can see how long they've been in use, 3 days and 10 hours each. And again, these persistent volumes were created when we deployed WordPress and MySQL. And if we take a look at the YAML files here and scroll up, you can see there was a persistent volume claim right here that was created named WP PV claim. It's a read write once volume and it's 20 gigabytes. And then down here, when we look at the deployment and the container specs, you can see the volume for this WordPress container is going to use this persistent volume claim called WP PV claim. And it's the same for the MySQL YAML file. it creates its own volume, and then the container inside claims that volume. If we clear the screen, and if we type kubectl get PVC for persistent volume claims, we can see there are the two persistent volume claims that were created from the YAML file. These are currently bound to specific persistent volumes, and they have the same capacity and access modes and age of the persistent volumes that we just looked at. Now we can also do kubectl describe on, for example, a persistent volume claim. And don't forget to add PVC in here for persistent volume claim. So we say kubectl describe PVC space and then the persistent volume claim name. And now we get a ton of details. Again, we see the volume or the PV that this PVC is mapped to. We can see the labels, which map to the specific application. In this case, it's a deployment called WordPress. And we can even see the name of the pod that has mounted this PVC. Now, we can also do the same thing if we copy the volume name here. And let's clear the screen. Let's do kubectl describe, and we will describe a PV and paste in the name of the PV, and then we get a ton of details on the persistent volume. Again, to create persistent volumes, we can simply do kubectl apply -f and then specify a YAML file with all the details on the persistent volume that we want to create. And in this case, it's a manifest file that contains not only a persistent volume claim, but also a deployment and a service. So those are the fundamentals of Kubernetes storage: persistent volumes, persistent volume claims. You can easily use the get command and the describe command to get all the details you need about persistent volumes and persistent volume claims. Thanks for watching, and I'll see you in the next lesson.